Hey, greetings to the universe. Welcome to the Incredible Academics YouTube channel, guys. This is what we're going to be looking at today. Determine the values of A, B, and C. I mean, this is one of the questions that most, learners, kind of like struggle with, right? And hopefully by the end of, this video, you shall have, learned a thing or two. So I want you guys to look at this. We've got a function, and as you can see, this is a turning point. This is a cubic function, and you can tell by the shape that the coefficient of x cubed is negative, right? And you can see that this is a turning point, right? And this is the second turning point. So, but remember, whenever the cubic function is kissing the x-axis, that tells you something, all right? And I hope you said the cubic function has got two x values, two roots that are identical. In other words, x is equals to -1 and x equals to -1 twice. And then there's another root that's there, which is unique. All right. So this is the turning point. Because we've got two turning points, like we need to be very careful. Guys, calculus is very easy, but you need to think. Hey, you need to think. If you don't take your time to think, you're gonna think calculus is difficult. So let's get right into it. So what we're going to do is we're just gonna interpret the problem and then start solve. So you can see that here we're missing the A, the B, and the C. Okay, the A, the B, and the C. So that's like three constants that we need to find. Okay, right. And the first thing that we're going to do is we're just going to substitute this point over here, right, into that equation. So we're substituting 1:4, and we'll see where that's going to take us. So in place of y we substitute 4, and in place of x we substitute 1. So minus 1 cubed, all right, plus a into 1 squared plus b into 1 plus c. So now this becomes 4 is equal to -1 plus a plus b plus c. So you can rearrange the equation and say, okay, a plus b plus c then becomes what? So the -1 goes that side, becomes 5. So we'll say this is our first equation. Okay, that's fine. Then we can substitute the second coordinate by the turning point there. -1 is to 0, right? Yes, but we could have actually done this. We could have said, okay, but that's probably gonna be a very long route. But we could have done this. We know that y is equals to what? A into x minus √1, right? And then x minus √2. One thing about me, I'm always on the lookout for methods that are not gonna take me too long. √3, it's like this, isn't it? But the a, we know it's -1, so basically we've got minus x minus √1, x minus √2, and then x minus √3. I'm just gonna see if this is actually gonna work. I mean, you never know with mathematics, but we know for sure that for this equation, because it's kissing the function is kissing the x-axis, there's two roots that are equal. It could be √2 and √1, right? √1 and 2. So let's assume that these are equal. So if the two are equal, that means we've got this situation: x minus √1 squared, right, times x minus root 3, right? And we know for sure that the root 1 is our negative 1, right? That's our negative 1. We don't know anything about that root over there. And then we've got what? Minus into x minus root 1. So that's going to be minus 1, which is what? Plus 1, right? Squared. And then x minus root 3. We don't know what root 3 is, but obviously we can substitute one of the turning points, okay, and find root 3. So let's substitute 1:4. All right, so 4 is equal to minus, and then in place of x we substitute 1. Remember, we're substituting 1:4. So in place of x, 1, in place of y, 4. So that's exactly what I'm doing. So 1 plus 1 squared into 1 minus root 3. Okay, so now you can see that we can simplify this further. So this becomes 4 minus so 1 plus 1, that's what? 2, isn't it? 2 squared, that's minus 4. And then that becomes 1 minus, let's just say this is R3. Okay, so we divide throughout by negative 4. Divide throughout by negative 4. So minus 1 is equal to 1 minus root 3. So what is root 3 now? Root 3 to the other side, so root 3 becomes 1 plus 1, which is equal to 2. So our root 3 is 2. So now we know our function is like this. We've got y is equal to what? Y is equal to minus. So we're just going back to what we had over there, minus, and then x root 1, x minus root 2, x minus root 3. So there we go. So x root 1, we know it's negative 1. So minus root 1, that basically means x plus root 1, which is 1. Right, and we know that the second root is the same as this one, so it's still x plus 1. And then the third root, it's 2, so it's x minus 2. So that's what we have. So we can break this down quickly. Minus, so we've got what? We're just simplifying that. X is 1 and x plus 1. So that's x squared plus 2x plus 1. Still going to multiply this with what? X minus 2. Right? X minus 2. So let's see what we're going to get. We leave the negative out. So x cubed minus what? X cubed minus 2x squared, then plus 2x squared minus 4x plus x minus 2. I hope we're getting the same answers. Then we still put the bracket there so that we multiply throughout with the negative eventually. So that's minus into what? Yeah, let's simplify on the inside. So x cubed doesn't have a common factor, but minus 2x squared and 2x squared. There's no any other square term. Right, there's no any other square term. Yes. So the 2 they cancel, so we've got minus 3x. Right, and then minus 2. Right, and then that becomes minus x cubed plus 3x and plus 2. Okay, so now we know that the a is what? A is -1, which was already there. Yeah, we're actually asked to look for, no, the a is 0, the a is 0, the b is the coefficient of an x squared term, that's 0. That's why the x squared term is not there, because its coefficient is 0. And then the c, which is the constant term, wait, okay, a is 0, and then the b is 3. Remember, the b is the coefficient of the x term, and then the c is the constant, which is 2. So we managed to find out a, b, and c. Right, but I mean, we can solve the very same problem slightly differently, right? We can solve the very same problem slightly differently, and hopefully I'm not wrong. Okay, hopefully I'm not wrong. I just want a piece of paper where I can actually show you guys why I'm saying we can solve it a little bit differently. Because remember, when we started, I wanted to kind of like solve it using the other method, right? Using the other method. So I was like, okay, let's substitute I wanted to use simultaneous equations. Okay, so let's see how it turns out. So now we substitute this one and that one, right? And so the first point that we're going to substitute, that's what 1:4. So we go back to our cubic equation, substitute the 4. So 4 is equal to -1. You guys remember what we got when we were attempting to solve this thing, plus b1 plus c. So you know, a plus b plus c is going to be equal to 5. So we'll just say this is our first equation. We're just going to say this is our first equation, and then we're also going to substitute what we call the point -1:0. So 0 is